In this last video, I'm going to do number 3, letter A, as one more example. And I'm personally going to pick the guess and check method only because I want to be practical. And I know, especially for those of us who are looking at these playlists, it's really obvious that the guess and check videos take way less time than the videos with algebra. That's not because guess and check is better, but I do think it appeals to some of our instincts, and sometimes it's powerful to know that about yourself. If you're just pretty efficient at guess and check problems, doing the problems that way probably will pay off. If you're more efficient with algebra, or if you just prefer to do things with algebra and you don't care if it takes longer, that's fine too. Just use the other examples that I've done in numbers 1 and 2 to guide you through number 3 if that's the method you're choosing. I'm going to show it with guess and check, but we should end up with the same answer regardless of which method you personally decide to do individually. If you want to do this problem with guess and check though, my suggestion is to translate the information into a table. That was the one thing that they gave us in all the other examples that we don't have here. So to interpret this as a table, first give yourself a table and label it with the traditional variables, the n and the t of n. That will help keep things consistent. When they give you a number, like t of 1 equals 200, what they're actually telling you is that the number inside the parentheses is the n value. So this is telling us n is 1. And the 200 is actually the t of n value. So I'll put that in the bottom part. T of n is 200. The same thing goes for the other clue that they're giving us. T of 4 means n is 4. And the 25 is the t of n value, so 25 here. So that means it's our job to figure out the second term and the third term and figure out a multiplier that works so that we can get all the way through the rest of the problem. Now, let's see if we can use a little bit of common sense. We have to get from a 200 to a 25. Arguably, that probably means that I'm going to have to do some dividing because 200 gets smaller to get to 25. So I'm going to think about dividing a number. That means my multiplier will be a fraction. That's okay. We just want to think about what we can divide by. Now, it's always tempting to think about what 200 can naturally divide by because that's usually a good first step. For example, like we could divide by 100. But 200 divided by 100 is 2. 2 divided by 100 is going to be a decimal, and that decimal is definitely not going to divide by 100 to get 25. So dividing by 100 seems way too big. Let's try dividing by something smaller. Maybe like divide by 10. 200 divided by 10 would be 20. 20 divided by 10 would be 2. But 2 divided by 10 would not be 25. So that's not going to work either. I'll think about other things I can divide by. 10 was too big, so maybe we go smaller. Maybe we go divide by, I don't know, something really small. Divide by 2. 200 divided by 2 is 100. Divided by 2 is 50. Divided by 2, hey, is 25. So that's why it helps to kind of think in extreme terms. Try something really big, try something really small, see if one of those works. Turns out dividing by something really small ended up working out really well. Dividing by 2 looks like it worked. Because again, 200 divided by 2 is 100. 100 divided by 2 was 50. And 50 divided by 2 was 25. So it totally looks like dividing by 2 is the pattern. Now that I know that I'm dividing by 2, I can make an important conclusion. That means that the multiplier of this problem is 1 over 2. Remember, if you're dividing, your multiplier will look like a fraction, 1 over whatever we were dividing by. So 1 over 2 because we were dividing by 2. Now we just need to find the initial value. The initial value is always the 0 term in the table, so I need to go backwards with the pattern. You could think logically that if you're dividing by 2 to go forwards in the table, backwards would be multiplying by 2. That could work. Or you could just guess a number. 400 divided by 2 happens to be 200, so you could guess that the initial value is 400. But either way, the initial value is definitely 400 because it's the number that makes the pattern continue backwards. So I know that the initial value, or I call it I, is 400. I know that the multiplier, which I call m, is 1/2. And now I know that I can write my equation. I'm going to steal from the structure I wrote in a previous question. Remember this structure? T of n equals I times m to the power of n. I'm going to steal that structure for my equation here, and I'm just going to fill in the numbers that are specific to this problem. So T of n equals I, initial, that's 400, times m, multiplier, that's 1/2, to the power of n. Now again, you can do this with algebra if you want to, but you don't have to. If you want to just stick with this guess and check, then I think you'll find that letters B and C work pretty nicely with the guess and check process. If you want to do it the long way, you can. It's up to you. You'll get the same answer regardless. So again, it's just a personal preference thing. As you're working, have the answer key open though, so that you can decide as you're working whether the method that you're using is actually helping, if it's giving you the right answers, or if it's hurting and it's giving you the wrong answers. Because if that's the case, you might want to switch methods and try something else.